So for this lesson, what we're going to do is we're going to take a set of numbers that are raised to an exponent, and we're going to investigate what happens when we multiply them together, as long as their bases are the same. This is the key. The base has to be the same, where these two here are the same. What is a way to simplify or deal with these kinds of expressions? Well, let's remind ourselves real quick that 7 to the first can be just written as 7. All right, and then we're going to multiply by the 7 to the third component here, which is 7 times 7 times 7. And we could simplify this all out, and what we'd find out is that this would actually end up being 7 to the 1, 2, 3, 4. 7 to the fourth would be the simplified answer here. Well, what happened? What did we do with these two exponents? Well, this is really what happened is we did 7 to the first plus 7 to the third. And this will work with positives and negative exponents. And we can test this out here a little bit. We could do 5 to the second times 5 to the minus 4. What does that mean? Well, again, like before, we have 5 squared, which is simply 5 times 5. And then we're going to multiply that by the quantity. Now remember our negative sign here on their exponents. What does that mean? That means this whole component down here goes down below. And then we're going to have 4 5s. And there they are. And we could rewrite this right here. Let's see if I can do it a little bit straighter this time for you folks. I'm sorry. And what happens here? Well, these two 5s can cancel 2 of the 5s below, and we're left down here with 1 over 5 times 5, or 1 over 5 squared. Now if we come back up here, and just like we did before, and we grab this original question and we take a look, and we apply this approach from this component, how's that any different? 5 squared minus, we're just going to combine the component, the two exponents are being multiplied together. A positive 2 and a negative 4. What does that leave me with? 5 to the negative 2. And yes, in fact, if we go down here again, that is the same as 1 over 5 squared. So this approach with multiplying two numbers that have the same base that are raised to exponents, all we have to do is really just add the exponents together. This is very similar to if we were working with division, for example. Now let's take a look. Let's try some division with exponents here. If we had 6 to the fourth divided by 6 to the second, what does this look like? Is this really anything different than we've seen before? Some of my previous students get sick of me because I keep telling them things that are the exact same thing, because the rules in mathematics don't change. Just expanded 6 to the fourth on the top, just like it's written right here, and 6 to the second down here at the bottom. All I'm going to do is I'm just going to simplify by canceling out the terms that are the same on the top and the bottom, and I'm left with 6 squared, or in this case, 36. How is that different? What have we done here? How do we get 2 out of a 4 and a 6? Well, really, all I've done is I've done 6 to the fourth, and I've subtracted the exponents here. Division, we subtract the exponents, whereas multiplication, we added. Now, why does that happen? Well, what does this really mean, this guy down here at the bottom? It's another way I could have written divide by 6 squared. Couldn't I have just said 6 to the fourth times 6 to the minus 2? And it really all comes down to the same exact answer. It doesn't matter which approach we take. It always comes back to the same rules. And you often find that in mathematics, once you learn a rule, just because there's letters, numbers, fractions, what have you, the rules do not change. They stay the same.